Hello and welcome to this 11th lecture on Java programming for beginners. Now, like every other programming language, Java also provides a set of structures, certain features that you could use to control program execution. We all know that programs usually start from the beginning of a file and execute down till the end of file, or in the case of Java, as we have seen, it always starts immediately after the opening curly brace of the main method and executes till it hits the closing curly brace of the main method. So this is sequential execution of our program. But now Java provides these control structures that you can use. You have statements, you have loops that you could use to override the default execution order. And that's what we'll be addressing throughout this tutorial. First, on the screen here, I have those structures listed. You have the if, the else if, and the else statements. You have the switch case statements. You have the for loop. You have the enhanced for loop, which was introduced as of Java 5. You have the while loop. You have the do while loop. You have the continue and break statements that will actually give you more power. And then you have nested loops, like loops inside loops. So we are going to go through all of these one after the other. And since the best way to learn how to program is to write the code, we would go directly and explain while we do the activities. So I'm going to bring out my NetBeans, and I'm going to clear out, I'll use my main method, the main method I have in the Java tutorials class. And I'm going to clear out everything that is there, so I have it empty. Now that it's empty, I'm going to create another method down here that we would use. Public void direct person. All right. Let's leave that for now first. Let's just keep the method down there. I want to show you something right here. Remember, when we talked about the comparison or relational operators, you're probably going to be using them a lot here. So I'm going to write a statement. First of all, I'll declare two variables, int x. X is equal to 5 and y is equal to 10. Then down there, I'll write a statement, if x is equal to y, then execute this. Now, okay, let me put something here, system.out.println, they are not equal. And here I would say system. Remember the S there is capital. Java is very sensitive. System.out.println. And I'll say x is equal to y. And now this is the basic structure of an if statement. First of all, the if statement is made up of the if keyword, a set of parentheses that must take in an expression that would resolve to a Boolean result. The end result inside here must be Boolean. You could either put a Boolean result there, or you use an expression, and you should be sure that that expression must evaluate to a Boolean. If that expression evaluates to something else other than Boolean, then it will not work. For example, if I use a single equal sign here, you see I already have an error. Why? Because I'm assigning the value of y to x. I'm not comparing it. And the result that we have inside here is an integer, and that's not Boolean. In some programming languages, you would see that 1 is treated as true and 0, or any integer apart from 0, anything other than 0 is treated as true, and 0 is always treated as false. PHP is a good example of that. But Java does not permit you to do that. everything you ever use inside the if statement here, inside the parentheses of the if statement, must always evaluate to a Boolean. Otherwise, you're going to have an error. So I'm just going to fix that back. Don't get confused with this assignment operator, which is a single equal sign, and the equals operator, which is two assignment operators put together. Like that, or two equal symbols put together. All right. So now, after, like I said, the if statement is made up of the if keyword, a set of parentheses that must take in a Boolean or an expression that resolves to Boolean, and then you have a set of curly braces that define the body. There's no doubt we're going to see that these curly braces could be left out if we have only one statement. But I'm putting it there so that you actually see. I'll explain that later on. So we have the if keyword, the parentheses, with an expression that will evaluate to Boolean inside there, and we have the body of the loop. Now, if this expression evaluates to true, the body of this loop will be executed, and we will see this message printed out, and after that our program will continue executing. So if I run this, I expect, well, x is equal to y. In this case, x is 5, y is 10. 10 is not equals to 5. So we expect this to fail. All right, so let me run this. Okay, now I just got it. And what do we have? They are not equal. You see, it's good. It does not get inside this block of code, and it jumped directly and printed they are not equal, which is good. But now let's change these to, say, no, sorry, that's not what I wanted to change. I actually wanted to make this, okay, let's leave it at that. Let's change this to, say, x is, well, we're using equals, so it makes more sense. Let me make it blend with the statement that is inside there. Now, this is 10. This is 10. So if we run this, x is equal to y, which means 10 is equal to 10. And we can correctly proceed without any problems. So I'm going to run this now. All right, it's good. X is equal to y. So we say if x is equal to y, in this case, x is equal to y. And what do we have? We have it getting into this block, and it's executing that without any problems. But now we have one problem. It's saying that they are not equal after telling us that x is equal to y. So then, we realize that there are situations where we only want this block of code to execute, but we don't want this part to execute. So how can we do that? Java is kind enough to provide us something. We could say else, and like the if block, the else block also has a body, like that. Now, what's going to happen here is, the program is going to start running. If x is equal to y, it's going to print this statement. If this is not correct, if this expression here evaluates to false, then this expression, this block of code will be skipped, and the else block will be executed, and we'll have this line of code here printed out. So in this case, you see that the problem that we had before, where it said they are equal, and then it came down and said they are not equal, will be taken away. So now, what happens is, if this one executes, this one will not execute. If this one fails, then we would execute the else block. So if we run this again, now we see that it says x is equal to y, and this part is never executed because this part has already been executed. If x is equal to y, do this, else do this. So this was satisfied, and it did not do this. And if we change this back to, say, x is, if we change this, let's say, to 5, and then we run it again, now you see x is 5 and y is 10. So is 5x equal to 10, which is y? The answer is no. So this expression evaluates to false, and this block of code is not executed. But now we see that the else block is actually executed. So you might want to, in cases where you have maybe two alternatives, do something, otherwise you do something else, you might want to apply the if else statement, and this is going to address your problem very well. Like I said, the expression here must always evaluate to Boolean, so you could always use something like greater than, less than, anything. As long as the result is going to evaluate to a Boolean, then you can correctly put it there without any problem, and it's going to execute. All right, now in this case we just have two options. But what happens if you maybe had multiple choices and you wanted to serve, let's say we're working in a restaurant, right? We're writing an application for a restaurant, and users could place multiple commands, and maybe the receptionist is, or the service person is going to take their command and go to the kitchen, get the food, and present them with what they commanded. Now we have multiple choices, and in this case, if we apply this, it means our restaurant only has two options. We could say two dishes. So what I'm going to do is we're going to define a series of strings here. String string 1, for example. Okay, no, I'll define integers. Int x1 x is equal to 1, y is equal to 2, y is equal to 2, k is equal to 3, and I'll leave it at that, just 3. Now what am I going to do here? I'm going to say if int choice. Good. I'll just take in one variable, the choice, and we'll leave it at that. Then we'll come down here, we'll say if choice is equal to 1, we would say, maybe I'll initialize choice to 1 first. I'll say system.out.println serve rice, and I would say else if choice is equal to 2. I would say this is not correct. This is supposed to be equals, not the assignment operator. System.out.println, and I'll say serve pie, and lastly I'll say else if choice is equal to 3, then I would say system.out.println serve noodles, and lastly I'll say else system.out.println, and I'll say serve water. Good. You don't have a choice, we get you water. Now what's happening here? Look at this. Now I have multiple statements or multiple choices, and Java offers an else if construct as well that you could use in conjunction with the if statement, and you could now do multiple tests. So in this case we are saying if the choice is 1, then this line will be executed. Else if the choice is 2 instead, so instead of executing this one, it will execute this one. And else if the choice is 3, execute this one. Now what happens? Execution actually starts from here and start going down. It starts from here going down sequentially. But what happens is it tests the condition inside the if statement here. If this condition satisfies, if this expression evaluates to true, then this block of code will be executed. And once this one is executed, it will never execute any of this again because the if statement has already executed. So it won't execute any of these again. Now, it will only continue these other tests if the first one failed. So if this one evaluated to false, let's say this was 2, for example, then it will come down here and it will say if choice is equal to 1, this will obviously fail because choice is not 1, choice is 2, as we can see from here. So it will do this test and this will fail. Because this test has failed, it will skip this block and it will jump directly to this block. And it will say else if choice is equal to 2. Now choice is 2 and it will execute this block instead. And once this block is executed, it would not execute any of the others. So if I run this, we expect to see serve pi because the condition there is 2. Same thing, if I change this to 3, what happens? It's going to run this one. It's going to run the first test here. It's going to execute this expression and then the result will be false because choice has 3 and 3 is not equal to 1. So if we say 3 choice is equal to 1, it's going to fail. This is going to return false, and because this is false, it's going to skip this block and it's going to get to the other part. And it says else if choice is equal to 2, and this will still fail because choice is 3 and not 2. So it's going to skip this block as well, and then it's going to come down here and it's going to say else if choice is equal to 3. Good. Now this evaluates to true and this one will be executed. So if we run it, we expect to see serve noodles, and that's what we have. But now what happens if choice is equal to 4 or choice is equal to any other thing that is not tested? It goes again, it tests the first one, this fails, this fails, this fails, and then because all of them have failed, it continues the test until it gets to the else block. Since no condition matched, it then executes the else block and this is printed out. So we now run this and we're going to see serve water. All right, and that is it. So you see that it tests each condition, and then if the condition satisfies, it executes the block of code for that condition. Now, there is never a day, once one block is executed, it would skip over all the others. We have seen that when this one is satisfied, it does not execute any of these. If it is this one that is satisfied, the second one, choice equal to, then it would skip the rest. So it keeps on testing until it meets a satisfactory condition, in which in this case we mean until it gets to where one of the expressions evaluates to true. If all the expressions evaluate to false, then what's going to happen is it's going to jump directly to the else block, and that's what it will print. It's going to print the else block. Now you will notice that all of these other blocks here are actually optional. The only compulsory part of the if statement is the if block itself. Like this. You could say if this, so if the condition does not satisfy, it's just going to skip and it's not going to have any other thing to execute. It will just continue executing other statements. But once you have an else block, then it goes. The else if block as well is optional. I could take that out. You see that it's optional, so it would execute this, and if it does not have anything, if this condition is not satisfied, then it would jump to the else block. If the condition is satisfied, it will execute this one and it will not get to the else block. So you see that the else block, the if else block, the else if block rather is conditional. It's optional. Same thing, the else block itself is optional. In this case, it's just never going to display anything if you don't have a choice, but we probably want to be nice enough so that we add an else block and tell our users that maybe please enter a choice between 1 and between 1, enter a choice from 1 to 3. Let's say that. I mean, this is polite enough so that the person knows that something is wrong. So in this case, if the person enters 4 or any other number, let's say the person enters 47 or 45, then what's going to happen? This test is going to fail, this one is going to fail, this one is going to fail. So it would automatically execute the else block. And now the person has a hint to enter something else. There's no doubt we are typing the figures right now. Later on, we'll actually see how you can enter the figures by typing them on your keyboard and then reading the input and processing and using it in your program. All right, I think that's simple enough, but before we go, or before we switch to something else, I just want to take off these things here, these curly braces. Ouch, I was doing a screenshot instead of... All right, let me take off all these curly braces that I have here. All right, as you can see, I've taken off all the curly braces, but my code is still very correct. Now, when you have only one statement that is controlled by each block, for example, the if block here has only one statement that is controlling. This one has just one statement. You can correctly take off the curly braces and it's going to work fine. But for me, I always put them there, even if I have one statement, just so you know. I'm telling you, just like it's part, that's what Java offers. So you should know that it exists even if you don't use them. There are certain features that exist and you should know that they exist even if you're not going to use them. So that tomorrow when you're working with some other person's code and you see them, you shouldn't get thrown off so easily. So like you see here, I have this, it's controlling just one statement. So I can go ahead and leave out the curly braces as long as I have just one statement here and it's going to work fine. But let's say I had to add another statement, system.out.println, and let's say I say you selected 1. Now you see I have an error. Java actually does not understand what I'm doing here, because after the if there's an else, then it should follow just immediately after all the statements controlled by the if block, by the if statement here. So now I'm trying to control two statements. My if block here has 2 statements, but then Java can only identify this one as a statement. That's why you see I don't have a problem. And if I come here, you see confusing indentation. My code is not properly indented, so Java itself is confused. But to solve this, I could go ahead and I add the curly brace here, and I add this one here. Now you see the error has gone away. My code now is fine. You no longer see the red lines. And everything is going to work correctly right now. Because I have 2 statements here, I add a curly brace here and a curly brace here. An opening and a closing one to define the body of my if statement. So every time a block of code, maybe the if statement, you're going to see this, it applies the same thing for all the other looping constructs we're going to see. Every time you have multiple blocks or multiple statements, every time you have multiple statements controlled by maybe a condition like the if statement, then you want to put them in curly braces to define the beginning and the end. Same way as you define the beginning of your method or the beginning and end of your class. Same thing, you define the begin and the end of this if statement. And the same thing holds true for all the other ones. All right. Now, with that said, we're fine. And the next thing we would want to look at next is, I put this thing here. I wanted to use this for some demonstration, but since we already have demonstrated what we wanted, I'm going to take it out. So now the next one I want us to look at is the switch statement. Now, like you see here, we are using the if statement to check multiple conditions. But to me, sometimes, or maybe to some other person, you will say the code looks so chalked up, and you can choose to use something else. And Java provides us with another construct that is really, really good. It works the same or in a similar fashion like the if-else statements, if, else, if, and else statements. And that's what we're going to look at next. So I'm going to take this off, all of this, and I'm going to type in switch. It's actually the switch case construct, and it has a body. Okay, I'll just type it all, then I'll explain exactly what it is. Choice, and down here I have case, maybe 1. Let's use the same 1 to break. No. System.out.println. I'll say serve rice. That's what we had earlier. I'll go, not that. Okay. System.out.println. You entered plus choice. Good. I'll copy all of this, and I'll just paste them down there as I go. So I could say case 2, and I paste it, and then I say case 3, and I paste it, and I'll change this to serve pie, and change this to serve noodles, and the last one is default, and system.out.println. I'll say please enter a choice from 1 to 3. And there's one last thing that I just forgot, my break statements. I'll explain all of this after I finish typing it out. Break. All right. Now we have it there, and let's see what's happening. We're doing exactly the same thing like we did with the previous example with the if and the else if and the else constructs. But now we are using a switch case construct to do that. Now, what is the structure of a switch statement? The switch statement starts with the switch keyword, like we can see here, same as the if statement did start. And then we have a set of parentheses that takes in a value. Now we want to be careful with this value. This value can only be a string, an integer, or a character. If we use any other thing here, we're going to have a problem. I'm going to show you that shortly. But before we get to it, you see that our switch statement has the switch keyword, a set of parentheses that takes in a value, which is the value that has to be tested. And we have the body, which starts from here on line 22 and ends down here on line 41. That defines the body of our switch statement. And then inside the body, you have the different test cases. Case 1, case 2, case 3, and you have a default which will be executed if no case matches. Alright, like I said, the value that you pass in the parentheses of the switch statement must be either an integer, a character, or a string. If you pass in any other thing here, it's going to fail. Let me change this, for example, to a float. Float. You see? Error. What's the error? Incompatible types. Possible lossy conversion from float to integer. That will never be allowed. And then, like I said, you could use a string. But now, when you use a string, for example, let me convert this 45 into a string. 45. When you use a string, everything that you're testing must be of the same data type as the value that is passed in. In this case, you see my cases are of type integer, but the value that I'm passing in is a string. It makes no sense in Java for you to try to compare an integer to a string. I mean, one is an integer, one is a string. It's 45, but it has been put in quotes, double quotes. Every time you put anything in double quotes, it's a string in Java. So even if I have the number 45 put inside there, it's no longer an integer. It's now a string. And if I want to use it as an integer, I must convert it into an integer. Remember, I said Java is a strongly typed programming language. Always have that in mind. So to solve this, I could also convert this into a string by putting the one in quotes. And now you see it's fine. If I do the same thing down here, you see that it's fine. And I could also do the same thing down here with 3. Sorry, with 3 in the double quotes. Now you see everything is okay again. That's just to lay emphasis. Everything you pass inside here, the value of the switch, the parenthesis of the switch statement, must always be of type int or character or string. If you pass a float or a double or any other thing, it will not work. You can pass a character, that's going to go fine. Characters are single quotes. You put characters in single quotes. When it's in a double quote, it's a string, no longer a character. So here you can only pass in a character, a string, or an integer. Obviously, if you pass a short is casted into an integer. A byte is casted into an integer. A long will not go because you cannot correctly cast a long into an integer. A long fits into 64 bits. An integer fits into 32 bits. So if you pass a long there, you're most likely to get into trouble. So Java will not let you do that. So I'm going to take all of this out and I'll leave it back as it was an integer before. And remember, like I said, the cases must always match the data type. The value of each case must always match the data type of the value that was passed in. And since we are on that, I also want to mention something. Int a is equal to 1, for example. Now, be careful. If I copy this and I paste down here, I'm going to have an error. You cannot use a variable here. You're not permitted to use a variable in the case. You must use the value directly. You can only use literals there. You cannot use a variable. So if you do that, it's going to fail as well. Just so you know. Alright, so now that we know that we cannot use a variable in any of the cases, I'll take that out. And let's explain how this is going to operate. Now, when you run this, you pass in the choice. What happens is the choice here is evaluated. And then when it gets to the first case, case 1, it compares the choice to what is here. And if the choice matches, then it's going to execute code until it hits break. It's going to execute this block. Remember, I have the break statement here. So let me put 1 here, for example. Let me put 1, sorry, is equal to 1. And if I run that, then it should print this set of statements because it compares the value in choice to this case value, which is 1. And if that matches, it's going to execute these statements here. Now let me run that. You see, it says you entered 1 and it says serve rice, and then it hits break and it stops. Later on, if I change these to, let's say 2, then I run it, what happens? You see, it says you entered 2. How did that go? It came here first. It said case 1. It tested the value. It compared the value, the test value, against this case. And the value is 2, but the case is 1. So it does not match this case, and it jumps directly to the next case. That's why all of these statements were not executed. And then it compares the value again. Like choice is now 2, and this matches, and it executes this statement, and then it says you entered 2, serve pie. And if we change this to 3, and we run again, you would see the same thing happens. It compared with this case, it failed. It compared with this one, which is 2, it failed. And then it compared with this one, which is 3, and this case passed, and it executed these statements down here. Now, if we change the case to 4, what happens? We run it again. Whoa, now you see, it came here, it tested 1, whoa, this failed. It tested 2, whoa, this failed. It tested 3, this failed. And then it jumps to the default block. So the default block is like our else block when we use the if-else statement. So every time no block is matched, when no case is matched, the default will be executed. And that's what we have happening down here. Now, you will notice that I have a series of break statements here. You notice that I have a series of break statements here, and every time I run the code, if there is no break statement, if we take out this break statement here, let's see what's going to happen. Well, okay, our case is 4, so it's still going to execute the default. Since it compares all the cases and nothing matches, it executes the default. But now, since I've taken off this break statement, I'll change this to 1 and I'll run it again. Now let's run. Whoa, what happens? You see, it took the first case, it compared, and choice is equal to 1. So this case matches. And what happens from there? It starts executing. It executes this statement, it executes this statement, and then there is nothing to stop it. The break is actually there to tell it when to stop for each case. Since there is nothing to stop it, it continues execution. It goes down to the same second place. Now it no longer, once one case is satisfied, it no longer tests any other case. It just keeps on executing the statement. So because this case was satisfied, it executes this, it executes this. There is no break to stop it. It's not going to test this case again because there was already a satisfied case. And then it's just going to go ahead and execute this and execute this. And then now it's going to hit the break. And that's why when we run this, we actually see that all the statements for case 1 and case 2 were executed. So once a case is satisfied, it no longer tests any case. It just keeps on executing till it meets something that will stop it. And in this case, it is the break that we have here that stops it. Now, if I take off this break that we have here and I run the code again, you would see now it executes everything. It starts from here, it tests, this case matches. So it executes this, and then it comes here. It no longer tests the case because this case already matched. It continues. There is nothing to stop it till it gets to this point, and then it hits a break, and that's why it stops. And if I take off this one as well, you would see that it would execute everything, including the else block, the default block. So always make sure you have a break there between the cases, unless there is a specific reason you don't want it. You could probably want to apply that in some, depending on your business needs, and it might just work fine. Now, let me change this to, and I run it again. Okay, now you see what happened. It tested this case. There's no break here, but it tested the case 1. It failed. After testing case 1, it failed. So it jumped directly to this case, and you see that's why these statements are not executed. And what we have here is you enter to serve by directly here. So like I said, once one case is satisfied, it no longer tests the others. For example, if I take this off now, you will see that it will execute what is here and what is down here for case 3. You see all of those executed. You enter to serve pie, you enter to serve noodles, because there was no break. But there was no break as well here, but because this case failed, it jumped and tested this one, and because this one passed, it did not bother testing this one again, and it kept on executing. And that is how simple the switch case statement works. But just remember, the value you pass into switch can only be one of 3 types: integer, character, or string. Don't pass in a long, don't pass in a float, don't pass in any other thing. You could pass in a short, a byte. All of those are integers, and it's going to work very fine. All of those can fit correctly into an integer, and it's going to work just fine. And remember the rule of the break statements. If it does not see a break statement, it just continues executing till the end. And remember also that the cases here must be of the same data type as the value that is passed into switch. In this case, choice. They are all ints, and you cannot use a variable here. For example, we declared a earlier and we tried to put it here. I'll do that again. Let's say int a is equal to 3, and if I try to put a here, I'm going to have an error. I cannot use a variable here. I need to use literals only. All right, I'm sure we got that. If you did not get it, go through the video again and try to practice some more. In the next tutorials, we are going to get into looping constructs, and we'll look at the for loop.